Hello everyone, and welcome to our video on solving a trig equation by using an identity. So in this equation, we see that we've got a sine of 2 theta and a sine of theta. So that makes them different trig functions because the double angle is special, and then that's just a regular old angle theta. All right, so when you have again, a mixture of trig functions or multiple trig functions, we do want one side to be 0, so that is good. So that's the same star there. But then after that, we often try to factor. All right, so here I can't factor anything, but I have a special angle. Now, this is a different case, so if you've been going in the same order as these notes or following my page the same way, we had special angles in the past. These special angles, though, were with a single trig function. Okay, so they were special because of that, and they were easier to solve. So we just wanted to get the theta by itself. We didn't have to use any identities. Whereas these, or this one, has another trig function. So it's a special angle and another trig function. So that usually means we need an identity. All right, so the identity that we would use, we know that sine of 2 theta is the same thing as 2 sine theta cosine theta. So if we apply this identity, that means I would have sine thetas in common. All right, so let's apply it. Let me show this in parentheses. So that right there is going to become that I underlined. We'll use our colors. So I have 2 and then parentheses. 2 sine theta cosine theta. And then minus 2 radical 3 sine of theta equals 0. Let's continue simplifying that blue. So the 2 and the 2 would just multiply like normal, so that's 4. So we have 4 sine theta cosine theta minus 2 square root 3 sine of theta equals 0. All right, so now all of our trig functions have a single angle theta, so they're no longer any special angles. And I can notice, well, again, we're often trying to think factor if you have multiple trig functions. Notice there's a sine of theta in common in both. And I guess there's also a 2 in common. So let's take those out. So we'll take out 2 sine of theta, and then parentheses, 2 cosine of theta, minus, again, I took a 2 out, so I'd be left with radical 3. And then I took out all of sine of theta. So that means the second term is just radical 3. Okay, so if I distribute this back in, let me just put dots. If I distribute it back in, it's a match to what's above. Okay, so 2 times 2 is 4, sine of theta, cosine theta, sine, yep, there it is. And then 2 times radical 3 is 2 times radical 3, and then sine of theta is attached. Okay, so it's good. And then now that I've got something that's factored, and if it helps, you can put that in parentheses too. But once I've got something factored, I can split those factors equal to 0. So I've got 2 sine of theta equals 0 and 2 cosine of theta minus radical 3 equals 0. Well, in the first equation, I could just divide by 2, and I would have sine of theta equals 0. In the second equation, I can add the square root of 3. So 2 cosine theta equals the square root of 3, and then divide by 2. Cosine of theta equals square root of 3 over 2. Okay, and then now I'm going to use my unit circle. Let's mark it with some colors so we can see it a little better on there. All right, so where sine of theta is 0, so that's y coordinates that are 0, would be on the x-axis. So angle 0 and angle pi. And then where cosine of theta equals radical 3 over 2, that's an x-coordinate where I have radical 3 over 2. That's in quadrant 1 and quadrant 4. Close to the x means 6 is involved in the denominator, so pi 6th and 11 pi 6th. There we go. So those are our 4 answers going around the circle. We would have theta equals 0, and then all solutions, so plus 2 pi k, comma, pi 6th, plus 2 pi k, pi, plus 2 pi k, and then 11 pi 6th plus 2 pi k. And there they all are. And then I don't know if I've said this in another video, the order doesn't really matter. It's nice to see it in order though. Okay, so if you wrote 0 plus 2 pi k and then pi plus 2 pi k and then pi 6 and then 11 pi 6, that's fine too. Okay, so they're all there. All right, and then just like the number 1, we could check it. So if we plugged in 0, it will show that it works. If we plugged in pi 6, it will show that it works, and so forth. Okay, so you have plenty of time, double check it. But since I'm out of space and we checked the previous problem, I think we'll say we're good to go. All right, so if you have any questions, please let me know. Otherwise, thanks for watching, and I'll see you next time.